Hello Astronomy 10, how are you? We'll get started with this. Felix Wozniak here, your instructor, and we're going to get going. We're going to take a tour of the universe, huh? Not too bad. Not too bad. We're going to do this a little bit old school. The camera on my computer doesn't work, but this camera does work. So we're going to endeavor to persevere, right? It's all going to come together. So let's do this. I'm going to put this on this screen and everything is going to be just great. Okay, here and now. Well, here and now where? Here and now in our universe, right? On planet Earth. You know, I remember quite some time ago, I was talking to my cousin, right? My cousin Margie. Margie is wonderful. Love her to death. And she asked me once, because she knew I worked in the space industry, she was like, Felix, wouldn't you like to go out in space? Now me, having worked in the space industry my whole life, and having used to thinking about that for many years, I told her, Margie, we're already in space. And she's like, oh, Felix, right? Yeah, so she kind of had this, she has this idea that I've heard quite a bit where, okay, we're on Earth and Earth is kind of the base. Earth is the base, and then space is out there somewhere and whatever, right? Space is fake news, it's conspiracy, no, right? So yeah, so really, somewhere hopefully halfway through this course, you're gonna think not in terms of space as being out there, but just space is this huge expanse, and we're right in the midst of things, right? We're already there. I'm sure I'm sure I'd like to go to the moon or something like that. But other than that, we're in space, right? So let's start here, right? So why are you showing this very innocuous picture of what looks to be a park bench, right? Well, let's talk about that. Let's talk about that. So here we have person on a bench, right? Okay, and they're saying this distance here is 16 meters. So 1 meter is just a little bit more than a yard, right? A yard is 3 feet, right? So one foot is about this much. So 3 of those is a yard. A meter is a little bit longer than that, the metric system, right? So here we have a person sitting on a bench in like a park-like sort of a setting. Here's a path, right? It's 16 meters. Well, why 16 meters? Well, that'll become obvious. What we're going to do is we're going to multiply this by 100, the distance, right? You're all used to Google Maps, or pretty much where you can narrow in on some area, you can go in and out of the map. That's what we're going to do. We're going to multiply 16 by 100. We're going to get bigger. So how much bigger is that going to be, right? Some amount. Let's go ahead and do that right now. Wow. Okay, well 16 times 100 meters is not, you now have 1.6 kilometers, right? 1,000 meters, right? We multiplied 116 by 100, you get 1.6 kilometers, right? Now here's why they chose 16. 1.6 kilometers is approximately 1 mile. Okay, a lot of us are used to thinking in miles, not in terms of kilometers. So 1.6 kilometers is equal to 1 mile approximately. So here we can see, this is a black and white photo, but that's okay. Here we can see here's like a track and field track, right? This looks to be a baseball field. Here's the diamond. You would play baseball here. There's buildings. So we're kind of used to this. This looks maybe a train yard, right? So we went from that little part of the park, right? And this is a college campus somewhere. I mean, that's what this is. And that was a student sitting on a bench in a college campus, right? Okay, well, I guess that's interesting, maybe, right? Why are we talking about this? Let's do it again. So we're going to multiply this picture by 100. So what do we think we're going to see, right? Maybe, I don't know, maybe a section of the city, or maybe, I mean, well, let's do it. We're going to multiply 1.6 kilometers by 100, okay? Whoa! So now we have 160 kilometers, right? So now we can see rivers, and there's sort of mountainous structures here, and maybe maybe there's a little bit of a city area here. So maybe this is where that picture was before, right? The little city in that college campus is here somewhere. And it's quite large. Well, okay. So what we're doing here is we're kind of getting used to distance, because guess what? You know this is astronomy class. We know we're going to study the universe and stuff. We know things are far away, so we're talking about distance. So yeah, so that's what's happening. That's what's happening here. Okay, so let's do it again. We're going to multiply this by 100 once more. Oh my God! Oh my, I thought maybe the country or something. No. So how many times do we click? 3 times? Things get big and or small quick. Earth is only 8,000 miles in diameter, right? Earth is actually pretty small. It's 8,000 miles from like here to here, or 8,000 miles from here to here, right? So Earth is only 13,000 kilometers, or approximately 8,000 miles. That's how big Earth is. Not very big. So here we see some clouds, right? The oceans, planet Earth, right? Well, at least now this is starting to look a little spacey. You're thinking, okay, well, this seems like astronomy now. At least we're looking at Earth. Earth is a planet, right? Earth is just a planet floating around in space, right? Let's do it again. Let's multiply by 100 again. Oh my God. Okay. Now we're definitely in space, right? So here we're seeing Earth, and we're seeing the moon, and so this is going to be 1 million miles from this distance to this distance. Now we've done that. It's going to be approximately 1,600,000 kilometers from here to here. So the moon is some portion of that. The moon is like about 280,000 miles away, right? The moon. Okay. And this just shows a picture of how big the moon is relative to Earth. The moon is quite big. Our moon is quite big compared to the size of Earth, right? So let's do it again. We're going to multiply this by 100 again, okay? Let's go ahead. And, whoa. So we just went, so our previous picture was here, where we had the Earth. The Earth is in this little square here, right? And look at this. Now we're getting really, make sure we can see this up here. Now we're getting really, okay, now this looks like astronomy. We have the planets Venus, Mercury, you've heard of that, right? Look at this also. Notice that Venus and Mercury are closer to the sun than to Earth. Now we're seeing here that the distance from the Earth to the sun is 93 million miles. Okay, well, we're used to miles. That seems kind of big. But here they're saying 1 AU. 1 AU is 1 astronomical unit. You're thinking, what? Why do we have to use an astronomical unit? Why not just keep using miles? We're used to miles, astronomical unit. Yeah, okay, I can hear your point. So how many of you are local to the area, like native to the Pittsburgh area, the East Bay area, San Fran, right? Raise your hand, right? Raise your hand, everyone who's native to the area. Okay, me. Yeah. So a simple question for you. How many inches is it from Los Medanos College to San Francisco? How many inches? What? I thought you people just raised your hand. You said you were local. How many inches? Yeah, inches doesn't make any sense, does it? Inches are useful. If I was measuring my computer screen or something, I would use inches. Or if it was something a little bit bigger, feet would be useful. I'm 6'2", right? So 6 feet 2 inches. So that's useful. We wouldn't measure me in miles. I wouldn't be 0.000 miles. But look, what happens is well, let's do it one more time. Just for right now, remember that 1 astronomical unit is the average distance from Earth to the sun. I say average because Earth's orbit around the sun isn't always the same. It's a slightly elliptical, so it varies, but it's 1 astronomical unit. You have to know that for the test, by the way. So why is that important? Well, let's do it again. Let's multiply this by 100 again. Oh man, look at this. Okay, So now the previous image was in this little area here, right? But look what happens now. You've heard of these. These are our planets, right? Mars, Jupiter, Saturn, Uranus, Neptune. Well, these are much more than just 93 million miles away. So if we were to say, well, Mars is this far away, Saturn is about 1 billion miles away. So if you're talking about this, you're just going to think, I don't know, it's a whole bunch of millions or billions of miles. It's very similar to inches, using inches to measure from the Los Medanos campus in Pittsburgh to San Francisco. Inches doesn't make any sense. We need a better unit. So when we're measuring things within our solar system, right? We have the sun at the center and all our planets and things in our solar system. We use astronomical unit, 1 AU. So that's why you have to know it. That's why it's going to be on the test, right? So astronomical unit is a much more useful unit. It's just like on Earth. We have small units, centimeters or inches for small things, bigger miles when we're going farther distances, right? Same thing in space. It doesn't make sense to use miles anymore. We're using astronomical units. Okay, but now notice, so we had, from the previous picture, we had the planets Mercury, Venus, Earth, then Mars, Jupiter, Saturn, Uranus, Neptune, as we go away from the sun, right? Okay. Let's do it again, right? We're used to this now. We're going to multiply this by 100 again. Oh no! Look how lonely we are in space. It's so lonely. So the sun and all the planets, we don't have any friends. We're just kind of out here in the middle of nowhere. Yeah. But Felix, when I look at the sky, when you're out of the city, right, and there's no light pollution, you see lots of stars. Yeah, but they're far away, right? So here we have the sun and the planets. They're all just kind of there. There's nothing. That's us, Earth, all by itself. Well, for a little bit. Let's do it again. Let's see what happens. We're going to multiply this by 100 again. Hey, we have some friends now. So here's some other stars. So the sun and planets are all in this little area here. Then there are some nearby stars. The closest stars is the Centauri system. There's Alpha Centauri, and then there's Proxima Centauri. These two stars, orbit around each other. They're a binary system. And you can almost think of it like Proxima Centauri is a little bit smaller. It'd be like Earth's moon going around, but they're a binary system. Two stars that are orbiting around themselves. So Proxima Centauri is the closest star to our sun. Our sun is a star, right? It's a star like many other stars, right? Where we are in space. Although from us we look up, it seems like space is out there, but clearly we're just like in space like any other star, right? Star. Okay, so how far is this? Well, here it's saying, what? Light years? We just learned astronomical units. Yeah, astronomical units works great when you're talking about our solar system, but once you get to the stars, it doesn't work anymore. It's now just same as inches to San Francisco. It doesn't, from Pittsburgh to San Francisco in inches, you're like, I can't remember that, who knows, right? Yeah, so astronomical units is very useful in our solar system, but it becomes useless. So 17 light years is here to here. Well, what's a light year? A light year, if you were to have a flashlight and you turn it on and aimed it out into space, and you had it on for 1 year, the distance that light would travel, and after 1 year you had a stopwatch or a calendar, you're watching your Google time, you turn it off. That distance, that's a light year. So it's not a measure of time, it's a measure of distance, but it's defined as the distance that light travels in 1 year. Light always travels the same speed in the vacuum of space, right? It goes slower in water, it goes slower through glass, and diamonds, it goes slower. But going through the vacuum of space, it goes at the same speed. So it's a very convenient to use that as distance. So this is another thing that's on the test, right? 1 light year. You have to know what a light year is. So anyways, so we're here, and our, Earth is orbiting the sun, so our solar system is here. There's a pretty close star called Proxima Centauri. If you were to hook your cell phone up, and say you had a buddy, Zork, right, an alien that lived on, there's no evidence for this, but let's say you had your alien buddy, an octopus kind of looking friend, right, living on Proxima Centauri, you wanted to send Zork a text. Well, you would send him a text, right? Say you hooked your phone into a big NASA dish, right? And you were able to broadcast out there. It would take over 4 years, 4.2 years for your signal. So Zork would be there, right? One of his octopus tentacles would go, hey, I got a text from my friend Emily, right? So Zork would text you back, right? So how long would it have been for that text for you to get a reply back from Zork? Well, it took 4.2 years for your signal to get to Zork. Assuming Zork answered it right away. Zork would go, hey, Emily, how are you? Yeah, just hanging out. Life is good, right? And so it would take 4.2 years for your text to get there. Zork would reply. It would be 8.4 years for you to text your friend. The signals that come out of your cell phone, those are electromagnetic waves. They're just like light, just different wavelengths. It travels at the same speed of light. All those electromagnetic signals all travel at the same speed, the speed of light. It's far. It would take so it's 4.2 light years away. It would take 4.2 light years for your signal to get there, right? Then let's say, so you get the message back, right? And then you're like, yeah, so you send Zork another text back. Yeah, things are going pretty good. I mean, in the last 8.2 years, I got married, had some kids, and now I'm divorced, but it's going okay, right? And then another 4.2 years, then Zork replies. So now it's been like another, and you get a message back going, hey, who is this? I lost my cell phone. I lost all my numbers. Send me the number. Right? Yeah, because it's so far. So our universe, although on planet Earth, it seems like light travels really fast. The speed of light is fast, instantaneous. But in space, because space is so big, there it seems like light actually travels slow. It would be 4.2 years for your phone signal to slowly travel. Then Zork, your octopus friend, would answer, your alien friend would answer your text. Slowly the light would travel back. So although it goes, because we're little, light travels quick as far as that, it seems like instantaneous, but in the vastness of space, light actually travels slow. And nothing can go faster than the speed of light. We will talk about that, don't worry. This is science class. Let's do it again. So and then there's some other stars. So there's other stars, blah, blah, blah. Let's multiply this by 100 again. Yay, now we got lots of friends. Well, this looks like the normal sky. But now what you know, so this is 1700 light years from here to here. Now what you know is that the distances between the stars is huge. So now when you look at the night sky, you see stars, you know those stars, not only are they far away from us, they're far away from each other. It also shows you it took a long time for that light to travel all the way to us. See, in this case, it would take light 1,700 years to go from here to here, right? So it shows that Earth is very old, that we're able to see very distant things. The light had time to travel to get here. Earth is very old. There's a lot of evidence that Earth is old. Tons of it. This is just one more on the pile, right? Let's do it again. Hey, what the heck? Well, that's it. So what happened is we are here. This is what we live in a structure called a galaxy. We live in a very pretty galaxy. It's a spiral galaxy. Now we can't see our galaxy. This is an artist's rendition. It's not a picture. But we mapped our galaxy from the inside out. We're going to talk about that in the course, don't you worry. We mapped our galaxy from the inside out, and to a fair degree of accuracy, it looks like it's a pretty spiral galaxy. If you looked at it this way, it's this spiral has like a central bulge and these spiral arms. If you were to look sideways, though, it would be very flat, like a disc. So just keep that in mind. So our galaxy is about 80 to 100,000 light years big, depending how you measure it. So 80 to 100,000 light years. That's the size of our galaxy. A galaxy is like a world unto itself. We have billions of stars, right? Our sun is just one star. There's billions of stars in our galaxy. Okay? And this galaxy is this pretty swirly thing out in space. And this is our home. We live there. And we live out in the suburbs. We're not in the central bulge. We live out here. Let's multiply by 100 again. And again, we're kind of lonely again. Well, a little bit. So what this shows, everything in this picture is a galaxy. This is 17 million light years now, from this distance to this distance. 17 million light years. Our galaxy's here, and it's showing the nearby galaxies. It's showing galaxy, 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 galaxy. Remember, each one of these galaxies, some are spirals like ours is, some are different shapes. We'll talk about that later. But each one are galaxies, and each one of those galaxies has billions of stars. Our sun is a star, right? So each of these dots is a galaxy, and then we'll find out there's billions of galaxies. Let's multiply it by 100 again. Holy cow, what is this? 1.7 billion light years. Each tiny little speck is a galaxy. There's a lot of stuff out there. I told you this was going to be a tour of our universe. Each little speck there is a galaxy. There's billions, and you can see there's some structure. It's like a web lake. They're not just randomly in space doing whatever. There's actually like a kind of a web lake structure. Okay, this is 1.7 billion light years across. And yeah, we got telescopes. We have, telescopes out in space and stuff, and we photograph all this, right? We get images of all this stuff. So these are each one of these little specks is a galaxy. There's billions of galaxies. Each galaxy is billions of stars, right? Let's do it again. Okay, that's it. That's it. So here, this is a picture. Except for this is a star, but all of these, this is a picture taken by the Hubble spacecraft. Hubble is a telescope that's out in space. It's been up there about 29 years, maybe close to 30 years. It orbits Earth, so Earth's atmosphere kind of can distort. When we're trying to look at space and we put our spacecraft above the Earth's atmosphere, we can get much clearer picture. So Hubble is a spacecraft that's above our atmosphere. It orbits Earth, and we're able to get very clear. This is a star here, but everything else here, this is a real image, by the way. This is not an artist. This is a real image. Galaxy, galaxy, galaxy. You can see very pretty things. Some are spirals. See, like this is a spiral, kind of like ours, very pretty, very pretty. Other ones are just kind of blobs, kind of a blob. This one's sort of a blob. Then the spirals, some are face on. If they're you're looking at it edge on, right, then they kind of look more like a disc shape, perhaps like this one or this one, depending on how they happen to be orientated in space. If they're face on, you'll see this spiral. If they're edge on, they're like a disc. Our galaxy is like one of those spirals where if you look at it this way, it's a spiral. This way, it's like a flat disc, right? Okay, so this is a real image taken of our universe. Lots of galaxies, right? I mean, look how many there are. They're so far away. These are millions. These are millions of light years away in this image. They're far, 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 and they go into the billions of light years away, right? You're used to millions and billions, right? Where we have billionaires, right? Your phone is like 4G, maybe going to 5G, right? That's billion. So you're used to, in your generation, you're used to talking in terms of billion, right? So you're used to those numbers. And here's just another one to show some galaxies. This is, like I say, this is a real image. Pretty things. Look at this. There's kind of like these two have, like they're kind of the gravities, they're pulling on each other, pulling them apart, right? Pretty things. Okay. This is what this is. This is the biggest structure of images that we've taken. Planet Earth is here. We are not at the center of anything. What happens is, remember I said our galaxy is like a disk? So our disk, what happens is that we can't see outside of our galaxy if we look this way or that way, because the stars from our own galaxy are in the way, because it's very long and there's a lot more stars there. But if we look up, this way or this way out of our galaxy, then we can see other galaxies outside. So that's the only reason there's no data here, because our own galaxy is in the way, right? If you're in your house, you can see out the window, but you can't see through the walls. Well, our galaxy is in the way, right? It's like the walls, but we can see out this way. It shows concentrations. What this is, galaxies themselves, they form like local groups, then those groups form clusters because there's gravity, right? Gravity works the way gravity is pulling my pen down to my hand. Well, it keeps galaxies together too. So they orbit each other, they're in groups, but they orbit in these huge superclusters. And superclusters, you end up with kind of this structure where there's huge empty areas in space, huge empty areas Then there's other areas where there's lots of galaxies all together. This here is called the Great Stone Wall. It's just this huge concentrations of galaxies, billions of them. This is the biggest structure that we've ever witnessed from our planet, called the Great Stone Wall. So folks, what that was a tour. That was a tour. Let's go back this way. Okay, so that was a tour of our universe. Here I am. So that was a tour of our universe. And yeah, so we went from, here I am, we went from Earth, our planet, and all the way to the farthest reaches. So now what we're going to do is we're going to fill in a lot of details. So the rest of the course will be filling in a whole bunch of mitigating details. This was a quick tour of the galaxy, but now things get interesting. Now we're going to start getting into the heart of the matter. So, all right, take care, and we'll see you next class. Bye bye.